Alright, so this is the lemon battery / light bulb experiment. All you need, 3 lemons, some zinc, some galvanized screws, that's screws with zinc on the outside, some copper, which I bent into the shape of pennies, since pennies aren't made of copper anymore, not entirely copper. What you're going to do, take your lemon that's cut in half, stick your penny in one side, your zinc in the other, and let's check the voltage. The penny is your cathode, the zinc is your anode, and just a sec. Stay still for me. And you got about 1 volt, 9.991. We're going to repeat that over here. Again, it's just a lemon, nothing really special about it. You can also do this with potatoes, but you need more potatoes because they don't give as much voltage because they're less acidic. And I've done this several times, hence having to re-bend my metal together. This zinc's actually going to run out pretty soon, I suspect. Just because every time I do the experiment, a little bit more of the zinc on the outside of these screws is eaten away. So each of these is going to be about a 1 volt battery, and I've got these really tiny LEDs that I'm going to hook up to this. So first we're going to get our alligator clips. I probably should have mentioned you're going to need these as well. So you go from your cathode to an anode, cathode to anode, and I'll show you already you've got more voltage. If this stays in place, you've got more voltage because of this. So before we had 1 volt, and now we have, if it stays nice and still for us, come on, over the limit, gotta go up. And this thing is not playing nice as far as staying still for me. Yeah, so you got over 2 volts now. There we go, 2.66 volts. Pain in the ass to get that to stay still because the wires just want to dangle all over the place. Let's move that knife so I don't slice myself open. That'll make this experiment a lot less fun. Cathode to anode, cathode. You gotta be careful to make sure you're not having your wires touching. So you notice these keep trying to rotate over. That's not going to work, because then obviously it's going to short circuit. Stay still. Cathode to anode, and let's make sure this looks all right on the video. move this guy out of the way. So you can see we've got all our lemons hooked up. Now for the final part, take one more alligator clip, and these are just alligator clips onto copper wires that are insulated. Take that one. I'm going to take one of my shorter ones over here just because it's easier to work with. And let's see what we get for, make sure this is in play. Let's see what we get for voltage. I'm not going to be able to hold this whole thing in view while I'm doing it just because it keeps trying to short circuit itself. I got it backwards, but it's saying 4 volts. 4.15, 4.16. Not too bad. I may have a short in there somewhere. Let's check that out. Make sure we're not shorting ourselves. Alright. Now here's the fun part. Take this little LED and take one clip here, another clip here, and it turns on. And just so you can see, I'm not pulling any funny business. That is just, it turned off when I dropped it because it shorted itself out, but you can see it's just lemons here. I don't have like a hidden battery anywhere. You saw me cut everything up. The only thing is when I put it down, it shorts itself out, but there, you can see that's lit. Turn the lights off. Oh, wrong lights. Alright, the video cut out before when I was going to show the full bit of this, so just so you can see just how bright it gets. It's not bad, and that's been actually running for a little while. I didn't realize the camera had cut out, but that's after, and there, I've turned it off, and back on, off, on. And just so I can prove that there are no shenanigans going on, so just a sec, I'm going to have to hold this on my belly. Alright, so I can prove that there's no shenanigans going on. See this wire right here? This connects from here over to here. So you can see that it's not that this LED just turns itself on when anything touches it. Turns off when I disconnect it from the anode. Turns off when I disconnect it from the cathode or rip the cathode out of the lemon, which I'm going to put back in. And that's it. The physics on how this actually works, so that I can get this nice little light going. Basically, you've got electrons flowing from, stop trying to short yourself out, you stupid thing. God bless it. There. So you got electrons flowing from through here, across that, and through here. So this is zinc. That's copper. Copper has a greater affinity for electrons, so when you've got a connection like this, electrons are going to flow from the zinc to the copper, but only if you've got them set up in a proper battery like I have here. So the reason that you have the lemon here, the lemon's not actually generating power. The power is coming from a chemical reaction between the zinc and the acid in the lemon that allows electrons to get released and sent over to the copper. So that the zinc's actually going to corrode as this reaction goes. Same way a battery works, like the AAAs you have in your keyboard or whatnot. Basically, one metal's getting broken down, and the energy from that is powering whatever you've got going. If you look up galvanic cell, that's what this is. So the salt bridge that you will read about in a galvanic cell, if you look it up, is just from the electrolytes that are in lemons. And Then you've got your aqueous solution, which in this is going to start having zinc in there because it's breaking down that screw. And then, like I said, you get this pretty little light. Fun. Isn't science fun?